Hello guys, and welcome to your second AP review video. Let's go ahead and take a look today at a couple of big things. We're going to take a look back at how to build a box and whisker plot on your calculator, how to use trace on that puppy, how to make a histogram using trace on that, rescaling your bin size for a histogram. We're going to build scatter plots. We're going to use linear regression, review how to get a residuals plot or an R-squared value for a scatter plot. We're going to take a look at, for Blair's sake, I know she has wanted to see how to use Geomet PDF, CDF, Binom PDF, Binom CDF, all of that. Let's see. And I think that's going to be the end of the video once we get through that stuff. Okay, so let's go ahead and take a look here first. We're going to spend a lot of time on the calculator. We won't need the Smart Notebook a whole lot. Let me go to Stat Edit, where you guys are totally familiar with building your list. We've got L1 and L2 set up. No worries there. We're going to go second stat plot, and we'll make sure that one plot is on, and also make sure you don't have anything set up in y equals. Throughout the whole AP exam, I can't imagine why you would need anything in y equals. If you would clear that out at least before the AP exam, some of you calc kids are going to make sure, or pre-calc kids for that matter, will probably want to make sure that you're using that before that point, but that needs to be cleared out before the AP exam. Otherwise, the calculator freaks out if you try to draw both a histogram and like a y equals sine of x curve onto your graph. Okay, so I'm going to go back to stat plot and make sure that this is on. A single one is on. We'll start with the box and whisker plot, and we're going to choose the first of the two. The first of the two allows you to see outliers in the box and whisker plot, as you've seen calculated in class, moving 1.5 times the IQR above Q3 and below Q1 to build fences, and then finding outliers outside of your fences. The second option, honestly, I'm not sure why the second box and whisker plot is really even there. You want to see the outliers. So we're going to include that. We've got X list will come from L1. I will quit out of this and then zoom stat it. And there you go. There's your box and whisker plot, which you can trace to get the lowest value. Your min is 169.5. Your quartile 1, abbreviated nicely for you, is 172.4. Median is 189. Q3 is 199.2. And max is 2055. Okay? So that's useful in case they're asking you to interpret a data set where maybe you've got the 5-number summary already set up to go. Maybe they've included min, max, Q1, Q3, and the median, and they want you to interpret what the data looks like. Well, that's easy to take care of. You can just enter your data into the calculator and then see what the visual is. All right, so there's your box and whisker plot. We're going to build next your histogram. So we're going to choose the third display. Okay, X list L1, frequency is 1. We will zoom stat this puppy, and there you go. There is your histogram, which you can similarly trace along this to find the count for each bin. N is equal to 2 in that case, along with the bin, min, and max values. It goes from 169.5 to 178.5. So you've got two values in that interval. Two data values in that interval. You got one data value in the interval from 178.5 to 187.5, etc., etc., etc. Okay. Now from here, if you go to Window, go down to X scale, you can change your bin size to be like 10. Let's see. Given that that was 36 values, let's see, or was it 5? 45. Well, let's change this to be like 12. Okay. Let's just change it and see what it looks like. Okay, so we will not zoom stat it, because if you do, it'll reset your bin size to be 9. We'll graph this, and there you go. We can trace along this. We can see that the bin size has changed to 12, 181.5 to just under 193.5. So the next bin starts at 193.5, etc. Okay, and there's your histogram. So you may want to resize the bins if you've got a situation where frequently it would be when the calculator has way too many bins, or in this particular case, if the calculator gives you 4 bins and you want to know whether or not you've got a nearly normal histogram as per some of the conditions for sampling distributions of means like we have seen recently, then yeah, you would either want to reduce the number of bins by increasing your bin size, increasing the X scale, or if it looks like this that you see on the calculator right now, decrease your bin size to increase the number of bins. Okay. All right. So yeah, there is box and whisker plots, histograms. From stat edit, we got two data lists set up. So let's go ahead and play with a scatter plot real quick. We'll change the plot 1 to be that puppy right there. The Y list will be L2, not resid. Okay, and we will zoom stat this, and there you go. There's your scatter plot. Here too you can trace to get your coordinate pairs, and it'll not center, but select for you the data values one by one and with a blinking cursor, which is kind of nice. You've got your X data, your Y data. So why would you want to trace in a scatter plot? Well, if they give you a data set and they ask you for the two variables to determine maybe what particular value is an outlier, it's good to be able to trace the data in the scatter plot so you can identify. Maybe, for instance, let me go back to it. This guy right here is just an exaggerated value. Maybe it's super low compared to everything else. Being able to trace and find its X and Y values allows you to pinpoint which data value might be really gumming up your regression line. Okay. So speaking of the regression line, let's go stat calc. Let's go down to linreg, and let's build a regression line here real quick. We've got L1 and L2 as our X and Y data. Frequency list, store regression. EQ. I don't know what the EQ stands for, but we're not going to worry about those last two options. We're just going to calculate here. And you've got A, which is your slope in this case, B, which is your y-intercept. It gives you an r-squared value, and it gives you your r value, your correlation coefficient. Remember that r-squared is one of the two things. Whoop! I just unplugged the smart board. Let me replug that back in. Okay, and we're back. So remember that your r-squared value is one of the two things you're going to check to make sure that a scatter plot is appropriate for a linear regression model. If r-squared is close to 1 or close to 100%, then that means that a lot of that bouncing around that you see over here is going to be explained by the regression line. Okay? The way to think about this, all of your y values, if they didn't change, they would all sit at the mean of y. Okay, but naturally they do change. You've got this point down here varies this much. This point up here varies that much. This point down here varies this much. Okay, they're not going to all just sit on y bar. So the regression line comes along and tries to explain where your y values will be. And most of the time it does a decent job. It explains this much of the variation in that first y value, where the rest is your residual information. Leftover information. Think of residual as leftover. In that sense, the term makes sense. Okay, your regression line tries to explain where the y values will be. Residual, extra information, it varies from point to point. Okay, here the regression line predicts just an eensy-weensy, a little bit of variability, and then the rest is explained by your residual. Okay, same thing is true down here. The regression line is actually off in this case. If I drew a correct regression line, it predicts your y value to be up, but you've got a huge residual in that case. You get the point doing its own thing, kind of a rebel. Okay, so there you go. There's how to use linreg. Anything else on that? Yeah, there is something else on that. If you want to build a residuals plot, you're going to leave the scatter plot, leave your X data, change your Y data to list resid, and then zoom stat, and there you go. There's your residuals plot. You can trace along here to find the residuals for. Wait. Why are we not tracing? There we go. Okay. You can trace along here to find your residual for any individual X value. Okay. All right. So there is scatter plot, box and whisker plot, histogram stuff. Let's now go to what Blair had requested. We'll go stat. Nope. No, we won't. Second distribution to Geomet PDF. Okay. Let's say LeBron James, LJ, King James has a probability of success on any free throw of something crazy high. just 90%, okay? He's a 90% free throw shooter, leaving his failure rate to be 10%. And let's say that we have independent trials for free throw shots. Is that a fair assumption? No, because fatigue and mental well-being, well, that's a big term, but psychologically, where the player is at a particular point in the game, that affects how he's going to play. Let's say we want to know the number of free throw shots he needs to make before he makes his first. And let's say we want the probability that if X is equal to the number of shots till first made, let's say we want to find the probability that X is equal to 7. Well, we should expect that this is going to be ridiculously low. If he's a 90% free throw shooter, he's likely to hit his first, he's likely to hit his second, he's likely to hit his third. But to answer this question, we can go to the calculator and we can choose Geomet PDF, because we want a single trial when he'll see his first success. Okay? It takes two things. It takes a p-value, it takes an x-value. The p-value is 0.9. The x-value is 7. Close this puppy up. And 9e negative 7 means that you have 9 with the decimal place being moved 7 times to the left. Okay? So you've got 1, 2, 3, 4, 5, 6, 7. Right over here, there's 0, 0, 0, 0, 0, 0. Okay, that's the probability that he make his first shot on the 7th attempt. Super low, okay? Now let's see what happens if we do the following. Let's say not Geomet PDF, let's say Geomet CDF, okay? Geomet CDF with the same p-value of 90%, the x value is 7, and we will paste that bad boy. And we get, oh, something so close to 1.24679. Okay, so if we want this is Geomet CDF, this is the probability that x equals 1 plus the probability that x equals 2 onwards and upwards till probability that x equals 7 equals to 9999999. Okay, basically a 100% probability that he's going to make one of his first 7 shots. Geomet CDF, C stands for cumulative. The CDF finds the probability that he make his first shot, or that he miss, then make his second shot, or that he miss and make his third miss, and then make his third shot, or that he miss, then make his fourth shot, etc., up till the probability that he miss, then make his second shot. Okay? So you get an extremely high probability that he would be successful for the first time on one of his first 7 shots. All right, now let's flip things on their head a little bit. Let's now say, okay, he's got the same probability of success for each free throw, same probability of failure. You still have independent trials. Now let's say that he is shooting a total of 10 times, okay? And let's say we want the probability that, let me redefine x. Let's now say that x is equal to number of shots made, so plural here, made of 10, okay? Let's say we want the probability that x is equal to 9, okay? Well, we can answer that question. Notice we're not saying makes the first 9 then misses the 10, or misses the first one then makes the next 9. This is a binomial question. Success can occur in multiple different ways. So we can go to binom PDF here, which takes 3 things: number of trials, your n, your p-value, which is 0.9 in this case, and then your x-value is, we want 9. We want to see 9 successes. Let's paste that puppy, and we've got 0.387. Okay, so the probability that he make exactly 9 of his 10 shots is almost 40%, which kind of makes sense. Some of you guys may say, well, that seems low. If he's a 90% free throw shooter, that seems like that's exactly the number he should make. Well, it winds up being the case that 9 out of 10 shots is the most likely number of shots that he will make. He could still, he could flub. These are independent trials. He could make 8 out of 10. He could do better than his average performance. He could get 10 out of 10. There are a lot of different ways he can make or miss for these 10 shots. All right, so now let's look at the question of, let's say we want the probability that he only makes 1 plus the probability that he only makes 2 plus onwards and onwards up till the probability that he only make 9, he doesn't make 10. Okay? Well, that question can be answered with the following. We can go to second distribution, binomial CDF, interpreted kind of the same way as the geomet CDF. We want to accumulate all the different ways we can see success at 9 or fewer. So we still have 10 trials. It's 10 consecutive free throws. P-value has not changed. He's still a 90% free throw shooter. The X value we're going to leave at 9. We'll paste that puppy and 0.651. Okay? 0.651. So there's a 65.1% chance he makes 9, 8, 7, 6, etc. down to 5 of the shots. So he's got a really good chance of hitting all 10. What does that come out to? 0.349. 34.9% chance to hit 10 out of 10. So again, 9 of 10 shots is the most likely. And that is partly because the expected value of this random variable, if this is binomial, is n times p. Yeah, that's correct. 10 times your 0.90